Problem number 48. Match each compound with one of the molecular shapes shown below. So here are two molecular shapes. Now here are the three compounds. You're given the formulas for each of the compounds. And in order to get the shape, the first step is you get the Lewis structure. And then once you have the Lewis structure, you get the shape. So here are the steps over here on the right. So starting with the chemical formula, you use the chemical formula to get the Lewis structure first. And then once you have the Lewis structure, you then determine the shape. So you should see the lecture videos on how to do this. Let's maybe before we get the Lewis structures for each of these, let's just see what these shapes are. Let's just give a name to these shapes. Now, this looks like trigonal planar to me. So you can use table 4.2, trigonal planar. I think I'll blow this up a little bit. So trigonal planar is when you have like a perfect triangle. Okay, there's an atom in the middle and it's connected to three atoms in a perfect triangular fashion. Okay, so that looked like the first one. And then what is the second one? So that looked like this one, right? Trigonal planar. So trigonal planar. And so are any of these trigonal planar? And then this one looks like trigonal pyramidal. If you go back to table 4.2, that looks like this one right there. Okay, where you have an atom, and it's also connected to three other atoms, but not in a perfect triangular fashion. Those three other atoms are kind of squished together, sort of like a triangular pyramid, trigonal pyramidal. And this atom in the center also has a lone pair as well, but the three other atoms that it's connected to are kind of squished together. So trigonal pyramidal. All right, now let's just go through the proper steps to get to the shape for these three. And then once we get the shape, we can see, is it this one or is it that one? Okay, so how about A? The formula is BR3. BR3. This, by the way, is called boron tribromide. So it's not monoboron. Remember, you can drop the mono prefix. Boron tribromide. The last element always ends in "ide." And boron has three. 1, 2, 3 valence electrons because it is in group number 3, A, group 3A. So there's boron in group 3A. And then the bromines are in group 7A, so they get 7 valence electrons. And bromines look like this. 1, 2, 3, 4, 5, 6, 7. Okay, so boron likes to form 3 bonds, and bromines like to form 1 bond. Well, that's perfect because we got 3 bromines. So let's go ahead and draw the other 2 bromines. Notice how I'm pointing the single electrons towards the boron. It's kind of matching them up, anticipating the bonds. Okay, here we go. So it looks like everybody's ready to bond up. Let's go ahead and connect the bonds. So there's the first one, there's the second one, there's the third one over here. And that's the structure. Now, what is the shape of this? Okay, so what is the shape of the central atom, the geometry? And the way you find the geometry is you count the number of atoms that it's connected to and the number of lone pairs. So I count, looking at the central atom, I count 1, 2, 3 atoms that it's connected to. So I'm going to write that down. Three atoms. And does it have any lone pairs? Does boron have any lone pairs? No. So 0 lone pairs. Now you go to table, what is that table? 4.1. Here, table 4.1. So here, this is number of atoms, and this is number of lone pairs. So look for 3 atoms and 0 lone pairs, and it looks like it's here. 3 atoms, 0 lone pairs. That's that trigonal planar geometry. So this structure up here is a perfect triangle. So let's go ahead and just label that. That's trigonal planar. Trigonal planar, and obviously that's C. Okay, so we'll call that C, trigonal planar. Now, when you draw Lewis structures, it can be good to also. So this is the correct Lewis structure, but since we know the shape now, let's draw the Lewis structure as it's shaped. So where the bromines are pointing towards the corners of a triangle. So you got the boron here, and a perfect triangle. Maybe you got a bromine up here, bromine over here, and bromine over there. That looks like a perfect triangle to me. And bond, 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 and then lone pairs on the bromines. And there you go. That's, I think, a little bit better than this. They're both good Lewis structures, but this one tells you the shape as well. So, trigonal planar. Now the next one is B. What is B? You got nitrogen tribromide and nitrogen. It's got 5 valence electrons. Okay, nitrogen is in group 5A. And 5 valence electrons. The bromines have 7. They're in group 7A. So you got let me move this down actually. Okay, the bromines got 7. So 2, 4, 6, and then 7. And that's good because nitrogen typically forms 3 bonds, 1, 2, 3, and you got the 3 bromines, which each like to form 1 bond. So let me draw in the other ones. Okay, remember what we're doing. We're starting with the formula. We're getting the Lewis structure first, and then we're going to get the shape. Okay, that's the stages that you go in. Formula, Lewis structure, shape. Okay, so we're in the Lewis structure stage. Let's go ahead and connect the bonds. Make everybody happy. Give them octets. And that looks like a good Lewis structure to me. It's got an octet. Octet. Everybody has a common bonding pattern too, so that's a good one. And now that we have the, what would happen here? Okay, now that we have the Lewis structure, what is the shape? So you look at the central atom, you count how many other atoms is it attached to. So I see three atoms. Three atoms. But this time there's one lone pair. So you count how many atoms and how many lone pairs on the central atom. So I count one lone pair. One lone pair. So going back to that table again. So three atoms, one lone pair. You scroll down here, atoms and lone pairs. Look for 3 and 1. Okay, there it is. 3 and 1, that's the trigonal pyramidal structure. Okay, trigonal pyramidal structure. It's kind of like if you had a tetrahedral structure, but you take away one of the atoms and you replace it with a lone pair. You're left with trigonal pyramidal. So the shape here is trigonal pyramidal. And that's shape D. Okay, over there. And you know, you don't have to draw this the way it's shaped, but if you do, you can use this as a guide, using dashes for atoms going back in the page and wedges for atoms coming out at you. So if you wanted to, it would look like this. Keep the lone pair. You have a bromine kind of, whoops, let me get rid of that. So bromine coming down here, one bromine kind of going back, and the other one coming out. And then you could put the lone pairs on the bromines. Okay, this step is not required though in the problem. You're just asked what the shape is, but you know, sometimes you will see Lewis structures, three-dimensional Lewis structures, I like to call them. But this is trigonal pyramidal. It's that one. And what's the last one? C is PBR3. So C, PBR3. The name, by the way, is phosphorus tribromide. Phosphorus tribromide. What was the last name? The last name was nitrogen tribromide. Nitrogen tribromide. Now we got phosphorus tribromide. So phosphorus is kind of like nitrogen. It's also in group, you know, 5. So phosphorus is gonna, you know, be very similar. This compound's gonna be very similar. The Lewis structure, I mean, of the molecule will be very similar to the last one because they're in the same group. The bromines are the same, but the central atom this time is phosphorus. Okay, and there you go. Let's connect everybody up, give them octets, make them happy. So 1, 2, and 3. Kind of sloppy, I guess. Okay, that's all right. So again, we got the same as we did last time. We got 3 atoms, 1 lone pair. That's 3 and 1. Whoops, get back here. That one. Okay, 3 and 1. 3 atoms, 1 lone pair. And that's again the trigonal pyramidal. Okay. Trigonal pyramidal, and that is shape D over there.